So that laughing out loud guy yesterday dressed like a lemon, so I figured I'd dress like a lime. This is my Dayglow shirt. Yeah? Just wait till we close the doors and keep the outside noise out. All right, it's a little after 9. This is going to go on till right before 2000, and only about 3/4 of the presentation is actually on SQL injection. The rest is my web application wax museum, which is a collection of interesting screenshots. Before I start, I'm Matt Fisher. I work for SPY. Everyone here knows who SPY Dynamics is, right? Right. The talk is on SQL injection. Yes, this is a real Google ad. Obviously, I was Googling SQL injection, and someone in some marketing department paid for the wrong search terms. Before I get going, how many people here work for the government, right? Gubbies. Any gubbies? Okay, Chris. How many people here are from the commercial sector? .com, commies, okay. And the rest of you are unemployed? Right. Amen, brother. I will be soon. I'm talking about SQL injection. SQL injection is a vulnerability, right? The earliest I could trace it back is RFP, right? It seems like all this stuff starts with RFP, about 6 years ago. But most recently, it's become a really big vulnerability on the web. The CVE these days is almost dominated by web app vulnerabilities. 2 weeks ago, I had the perverse pleasure of sitting on a panel full of CTOs of different companies, right? And that's how we play. All these other companies sent their CTOs, and we sent an SE. One of the guys on the panel was Robert who runs the CVE database for MITRE. And he had some really interesting stats on the CVE. The majority of the CVE these days is cross-site scripting, and the second runner-up is SQL injection. Now, there's an article written about that as a result of that panel that mistakenly said that cross-site scripting is the most exploited vulnerability out there. The journalist heard that was #1 ranking in CVE, #1 vulnerabilities in the CVE, but it didn't really understand the nuance that CVE is a collection of known vulnerabilities in COTS and open source software that necessarily reflect real-life attacks. I do a lot of web assessments. Everybody in our company does. Billy and myself do plenty. And I've been doing some incident response recently, kind of pro bono for different agencies and facilities in the DC area. And I'm seeing way more SQL injection than cross-site scripting. I'm seeing more SQL injection than anything else when it comes to web app side. I can't attest with any credibility to the network side operating system attack. When it comes to web app attacks, SQL injection is it, because it's targeted. You don't have to mess around with any social engineering or any third party, right? Script attacks attack end users, bouncing things off the server, so to speak. SQL injection, you're hacking that box. And it's fairly easy to detect. It's fairly easy to exploit. And it's a devastating attack. The big thing about web application vulnerabilities, of course, is that your typical models only go so high, right? Network security, operating security, and the sort take care of the daemon, the operating system, but they don't address the application itself very well. And SQL injection is a web application vulnerability. SQL injection exists in the web code. The first myth, it's a very kindergarten myth, but a lot of people actually believe that SQL injection reflects a problem with the database server. That's not the case. SQL injection comes from the way you build your queries in your web code and you send it off. So it's a vulnerability that exists in the application that can be exploited over 80 or 443 or any other port from any HTTP client, whether it's wget, Internet Explorer, or my cell phone. The really cool thing about SQL injection, though, is it completely bypasses the perimeter. It shoots right through. When you perform a SQL injection attack, right, you're browsing through a set of firewalls, a set of IDSs. Most likely, it's redundant pairs of firewalls, and you're using access they have to give you to use the application, again, on any port. And then you're tricking that application into running your database commands for you, running your database queries for you. That application uses the exact same access, the exact same authentication and login to the database that uses for its normal work, right? The application has to have privileges in connectivity to the database for the web app to work, and you're simply riding on top of that. So you don't see new ports being opened, you don't see new attempts, it's all writing pre-existing stuff and gets you right through what could potentially be 4 sets of firewalls, 2 sets of IDS/IPSs into that database. And from there, of course, you can get data. You can do a lot more than get data, though. And once you are on that database, it's unfortunate. You go to conferences, you read papers, and everyone says defense in depth. Everyone understands that you need to defend more than your perimeter. But in the real life, right, I bet most of you go back to your office, and the big emphasis is on perimeter security. You can't do what you can on the inside. But the vast majority of organizations I've seen are very strong on the perimeter and very, very weak inside that. And once you get into the database server, if you start hopping from there, you're pretty free and open. Now, SQL injection is about running arbitrary database commands. It's not about reading credit cards from a database. That's one of the arbitrary commands you can give. But SQL injection allows you to run arbitrary database commands. Like an overflow gives you, remote arbitrary commands on a Windows system or a Linux system. And there's a lot of different types of commands you can use. But the most important thing to take back, if you haven't figured this out yet, is that SQL injection is more than reading the database. It's arbitrary commands, any commands available to that web application. It's not a database vulnerability, it's a code vulnerability. You cannot fix SQL injection on the database server. You can mitigate it. You can restrict what someone can do once they've injected by doing basic things like having multiple logins with least privileges. The core vulnerability in SQL injection is not input validation. And I might be going out on a limb. Some people may think this is arrogant of me, but input validation has nothing to do with SQL injection. SQL injection is about handling data safely, just as cross-site scripting is, just as doing file commands are, right? If you're taking input and how you have to handle that data safely. Input validation is a mitigation against unsafe data handling, right? It's knowing that my query may not be proper, my responses back to the page may not set their encoding type properly, or I might not be sandboxing my file access properly. Input validation can certainly mitigate SQL injection. It can certainly make it more complicated, and in some cases, it can prevent SQL injection. But it's still not the fix, and it's still not the problem. SQL injection is a result of concatenated variables into dynamic queries. It's called SQL injection because of the language used. It has nothing to do with MS SQL Server. It's not an MS SQL Server specific issue. It relates to all databases that speak SQL. You can even do SQL injection against Access databases. Access speaks SQL, and you access it through ADO just like any other database. Believe it or not, MS Access is a little more difficult to do injections against, though, because it doesn't have any system tables you can enumerate from the outside. So it makes it very difficult to figure out the lay of the land and do a reconnaissance. I'll talk about more about that later. The general techniques of SQL injection are the same regardless of the database you're going at. Some of the specific things will change, however. The semantics, the syntax of the commands. Obviously, the procedures and functionality on the server you can use. The schema will certainly be very different. The permission setup will be very different. Techniques apply to all databases. There are two basic types of SQL injection, verbose and blind. Some people call verbose error-based. Like if you use Squeal or Absinthe, Numish calls it error-based SQL injection. I think he's changing it to verbose. Verbose SQL injection is what pretty much everyone knows about when they first learn about SQL injection. It means that you get exceptions back. You get those ASP 500s with the ODBC error message in them, and those error messages are very useful for figuring out attack things. However, there are certainly applications in the wild, in labs, and in QA all over the place where they've done some good basic error handling, right? They're using a try catch finally and on resume next. They made the IIS and the Apache config changes so that there are no ODBC error messages, but they never went back and fixed the core query, which is the core vulnerability. So as a result, they've killed the symptom of the problem, but not the problem itself. So it's as if they, like when you break your leg causes pain so that you know there's a problem. If you take a painkiller, there's no pain. The pain goes away, the problem is still there. If you simply suppress errors without fixing your queries, you're still just as vulnerable, but the exploit technique is very different. It's what's called blind SQL injection. We have white papers on SQL injection on our website. They're really good. The white paper on blind SQL injection is killer, and they're both available on our website. On with me so far, by the way. There's some pretty technical stuff. Everyone got the ones and zeros and all that? Right. It gets better, I swear. Now, finding and exploiting SQL injection is fairly simple. The finding part is easy. The whole thing about SQL injection is finding dynamic queries. That's trivial in web applications these days. In this sample query, there's a parameter called error code, which is passed from a redirect, and that parameter tells the database what error code to retrieve and print. The actual code that does that looks like this, although in reality the X's are replaced with other values. You set up your ADODB connection object, right, which is basically the networking connection to the database, and you give it the query you want to execute, the static part of the query, and you pass in that error code to the query. Then later in the HTML section, you open that record set. In this code, we loop through that record set and all of the results back. When we're at the end of that record set, we close out our objects and destroy the objects to free up a little memory, and then we continue with our HTML. And this is how you get that bad username right in the middle there. That bad username comes from the database. The rest is static HTML. This is basic stuff. And it's a very common way of doing a database query. A lot of dynamic queries are built this way. It's pretty simple. The static portion of the query that never changes, right? You build that out as a constant, as a text string. It's static, so you hard code it. Select error message from error messages where error code equals. The only part of this query that actually changes is the error code itself. Now that comes from the browser. The application may pass it through a redirect, or it may pass it through a link or a form, but it's coming from the request object. It's coming from the browser. So you take that error code and you slap it on the end of the query, and you pass it to the database. You see this in textbooks. You see it in papers, websites all the time, presentations, and it's a generally accepted way of doing things. It's a very commonly taught way of doing dynamic queries. But it's actually the worst way you can do one.
Actually, most of the MSDN sample code tells you to do it this way.
Yeah.
Which is funny, because even experienced developers think this is the way you do SQL.
This is actually the worst possible way you can build a dynamic query for a couple different reasons. Security-wise, it's really bad, and we'll go through that. But it's actually low performance as well, because it has to be compiled on the fly, and the execution plan has to be built on the fly and everything. It's a poor way of doing things, but regardless, right, if that's what you see, that's what you do. And frankly, a lot of developers are out there self-taught. I'm completely self-taught, but I don't call myself a developer. I don't call myself a hacker either. But regardless, this is common. And as Billy said, I have books that'll show you queries like that, and then they'll say, in reality, you do a lot of extra security stuff.